Alrighty, welcome folks. Welcome to another remote module here. As we are getting started with the semester here, we are going to jump into module 2. So without further ado, it's nice to see you again virtually, and let's go ahead and dive into our code here. So go ahead and get rid of this here, and let's go ahead, just start from the very beginning here. For those of you who are just joining, maybe on the wait list, again, go to teaching, and then you'll find our wonderful class here on programming in C++. So go ahead and open up the page here. You'll notice that our previous lecture in the playlist is here. Otherwise, you can get to the various modules by directly watching them here. Once we are in person again, then you'll be able to, just get the recordings from here as well. So that's how that'll work. And as always, don't forget to do your in-class activity. These are due a week or so after they are released. So your next one here that was released on the 7th, for example, will need to be completed by the 14th. All right, so with that said, again, we are in the no in-person mode, which means we are, while you're watching this recording, so let's just go ahead and dive in. So let's go ahead and begin the module. And today we're going to be talking about, the batteries included part of C++, a part that I think is often forgotten with this language, and something that I want to emphasize early, STL and how to debug. We're going to start from the beginning of this class learning these different skills here. So with that said, there's a few different resources. There's a GDB video here on debugging. And actually, there's one other one that I want to add here. So let me just pause for half of a second here. I'll have to do this manually here. Sorry, no fancy editing. And now that we're back here by the magic of pause button, there is something for the LLDB debugger. So by the time you see this video, there will also be this resource. In this class, we're primarily going to use GDB, but if for some reason you have trouble getting that set up, and this will likely or could be the case for Mac folks, LLDB is the sort of native debugger on Macs. So this is the video that you would want to use here, so I will link to it so you have two resources. All right. Because for the most part, I'm going to be showing you how to do things in GDB, which is this debugger. Again, you can click on the window and watch the thing here. We're not going to let this play because I'm going to show you, but that's just an option or something that's available. All right, with that said, again, we'll have another in-class activity, so make sure that you complete that, and let's go ahead and dive into our slides. And it might even be useful, again, if you're watching this remotely, something worth doing, maybe just going into these in-class activities here. And you can kind of like keep this open or whatever, just to make sure that you complete it or don't forget it. It's just a way to kind of test your knowledge. These things aren't meant to be super, super stressful, but just test enough that you get the key ideas. Some code from this repository or from this lecture will be in this repository. Then I've added some notes. Again, I won't always add notes. Sometimes these are things like you might see me do little to-dos here because I'm thinking about things. But these might be fun little things for you to read when I provide them. Not every module is going to have them. Sometimes I go back in other modules and edit them as well, but they're there for you for fun. Alrighty, so with that said, let me go ahead and just, let's just go ahead and dive into this here. So here's our course, and a little bit of a pre-class warm-up here. This is a tool. I'm going to talk about it more later, but just wanted to kind of show you because I think it's exciting and cool and something that's fun that I'd rather show you earlier than later. You'll appreciate the tool later, but let's just go ahead to godbolt.org here. And it's a little website where you can type in C++ code and actually execute. You can click this output thing, compile it to binary, and then execute the code here. And let's just go ahead and write our hello world as a little reminder of how we did that. Hello world. And then we did a little end line here, something like this. So this could be a way to, this isn't the optimal way to write your code. In fact, this isn't a great place to do it for your assignments. What this is great for, though, is just doing little experiments, and then you can share the code, for instance, with these little links here. And let's go ahead and click on the output here so you can actually see that we got hello world. So anyway, this is just kind of a neat tool. And you can see how this code here, this C++, actually is getting compiled down to this machine code, and does a nice job sort of highlighting over things if you want to just see some of the basics here. This is actually a great way to learn assembly here. So let's make a really simple program here. Just create some integer or something. And then you can kind of highlight over the 72 here, and you'll see what that looks like here. Now it's putting it in hexadecimal. Anyways, not something that you really have to care about, but again, just as a fast prototyping tool, if you want to test out ideas, this is really cool. And it's made by Matt Godbolt, the man with the coolest last name I think I've ever heard. Anyways, as a tool here, so it's kind of neat. Alrighty, so last time we were working on Administrivia, right? So we learned about the course webpage, so make sure that you check that out if you haven't already, or if you're just joining us, make sure that you acquire the mono repo. Again, where was that? From our course webpage. Under the course information, if you click on that, this is where you'll want to acquire your assignment 1. And as a reminder, you'll be paying attention to the roadmap here, and notice that assignment 1 is due September 15th. All right, so a little bit later this week, you still got a little bit of time to do that. Now we got a little bit of a crash course, just looking at some things like hello world, loops, arrays, etc. Just to kind of start getting a feel of what C++ is. We'll start accelerating in terms of some things that we're going to do. But again, today we'll also sort of tour the language a little bit, just to sort of understand the feel and start to understand what things are important. All right. So as mentioned, make sure you get that mono repo, and you are completing your in-class activities and assignment 1 very shortly. All right, so today I want to talk about the C++ standard library, okay? And here's a look at it. Now, how did I get to this page? Well, this is something we'll become familiar with, CPP reference. But this is what it looks like. And right now to you, this is going to look like, oh my goodness, look at all these different things I can click on. But the reality is this is actually a nice page. We don't have to understand all of it right now, right? That's not the goal here. But we will try to understand some parts of it. Okay, so let me go ahead and click on something that might be a little less scary here that we'll look at. Array here, okay? And we can see what an array looks like. We'll learn how to read this stuff later. But there are nice little examples, and you can, again, run this code here. Usually it works here, and you can kind of play with the samples. Sometimes it doesn't compile it. Usually it'll give you an output here. But anyways, so this is just kind of a reference here. And again, what I'm showing you is this is all the stuff that you have available in C++. So it's kind of neat that we don't have to build a lot of this stuff from scratch, okay? You're going to see more interesting stuff like handling files, or doing concurrency, or regular expressions, all the math things you might want to do, some algorithms, a bunch of these data structures. These are all things that are available to us in C++. So really today's goal is just to see that, C++ is what I call batteries included language. That was a common expression with some other languages like Ruby, but C++ is really the same way. We have all this stuff built in that we can make use of. We just have to know it exists, and that's part of today's purpose, to know that, hey, this stuff exists, and we, C++, the folks who built these, they want us to use these things. These are things that are tested very well, right? So you don't have to build all of your data structures from scratch, okay? Some of you might be familiar with building a list data structure from class. Likely you're familiar with using one, in Racket or Java, or array lists, these types of things. But we have equivalent data structures built in to C++ here, okay? So here's another look at the standard library. So if that website was scary, here's just another reference here, C++, and you'll start to get a hang of what these includes are. So for example, IO stream was one that we used for our hello world, so we could kind of look through that. That had something to do with input and output, so let's go ahead and click on that, and you'll go ahead and see IO streams here. So you could use this to sort of navigate and see, oh, okay, what was that cout thing, and it sort of describes what it is. Sometimes there's an example here, and we're using modern C++, so usually you want to click on the C++ 11 thing here. So that's just a little bit of stuff to know about here. And you could, and as you explore this, you'll say, okay, cout, what about cin? Okay, maybe that's how we handle input, okay? And you can kind of see some examples there. And then you can kind of get guided to from the tutorials, or just kind of searching around from each of these sites to see some examples. So just two different ways to see what's available in C++. All right, so the standard template library. So also related to the standard library that I just mentioned, but this is abbreviated the STL. So this is the actual implementation of that standard library that's available. So I got to give you a little bit of history here as we move forward, just to understand what the importance of this or why we like using this standard template library that I'm introducing to you today. Okay. So the short history is that, about 1993, this didn't really exist. So this very smart guy, Alexander Stepanov, and you can read his wiki. He's got all sorts of legends about how he taught himself, to read different languages and days and stuff. But anyways, he presented a generic library to the C++ standard committee. Okay, basically said, hey, we need this thing here, all these different data structures and algorithms that can be, supplied with C++, okay? And the goal was to sort of standardize that, because of course companies built their own algorithms and data structures and stuff, but there should be some sort of like uniform thing, okay? And anyways, the key word here is generics, okay? So you maybe recall this from Java, right? This is what lets you create an array list and sort of decide, hey, is that array list going to be a collection of integers or maybe strings or something else, okay? We should be able to use that same idea of just storing information in some container in a sort of generic way, okay? So that was the idea here. All right, so he's sort of responsible for doing this, and then it's been sort of evolving over time as we get into the modern day implementations of the standard template library here. So all the compilers we use, G++ or maybe use Clang. This is Microsoft Visual Studio. They ship with pretty good implementations of the standard template library that we're going to be using in this course here. Okay. Now again, in this course, I don't care as much. It is worth designating that standard template library versus standard library is different. So I'm not going to test you on this. This is just sort of a disclaimer slide. So you can tell me standard library or STL or standard template library, and I'll know what you're talking about. Other folks will know what you're talking about as well. All right. All right, so let's go ahead and do sort of a basic crash course. That's sort of the goal today, to just look at some examples here. Now, there's quite a few things in the standard template library, but what I'm going to teach you as far as being a C++ programmer and sort of thinking like a C++ programmer is really 3 ideas. And I stole this slide because it's just so good from Bob Stiegel, who's a colleague also at CPPCon usually. Sort of gave this idea that there's containers where we store information. There's algorithms, which are things that you're familiar with, like searching for data or sorting data, or any kind of algorithm that you can think of. And then there's iterators, which are sort of the connectors between a data structure and the algorithm, right? So the idea is an iterator, as it sounds like, iterate would say, hey, look through this container one element at a time. The iterator is what helps you move, and the actual algorithm is finding something or copying a piece of data or whatever it might be here. Okay. Today, though, I want to focus on the containers portion, though, just to sort of constrain us, and then we are going to talk about iterators and algorithms throughout this course, of course. All right, so built into the standard library, or what's sort of supposed to be supplied with any STL, is this selection of containers. Okay. Now some of these are going to look familiar, right? Arrays, lists, maps, which are sort of the same thing as a dictionary in Python, or hash map in Java that you might have seen. Then things like queues and stacks and so on. So we have all the sort of basic ones that we would want here. And vector also is a very important one in C++. This is a resizing array. Okay. Now, depending on whether you've taken the data structures course or familiar with these, we'll have to do a little bit of a refresher here, which is what I want to do here. So let's go ahead and just start with arrays, which are just built into the language. So this is even outside of the STL. Okay, and what's an array? Well, if I create something like this, int array 9, this is saying, hey, give me a contiguous chunk of memory, and that's important that it's contiguous, with 9 elements in it, okay, to store my array. Okay, and then this is what I got here. So you can see, here's the index into the array, and we start with 0 in C++, 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. and then I can populate these items here as I have done here. So I access the raw array, and then with the brackets, I access or set the memory there. Okay, so raw array at index 0, I put in this little box A7. Okay, so that's what I'm doing here. Now, the important things to know about arrays in C++ is that you can't resize them. Okay, so this is always 9 elements. It doesn't get any bigger, right? This is the contiguous chunk of memory, this box here that I get here, somewhere in the memory in your machine where all the information is stored. And if I try to access something outside of this array, say, raw underscore array at 1000, well, I don't have a index here into the 1000th element, right? That'd be index 999. So I'd probably get an error, or the program would crash, right? Likewise, if I do less than 0, it would also crash. All right, so some other data structures, just to again get you sort of refreshed here, are linked data structures, right? So we have these contiguous data structures, arrays that put everything together in a contiguous block. But I also have these linked structures, okay? And these would be using something known as a pointer. Now we've got to talk about pointers. That's going to come up. Later we'll talk about this as a general mechanism. But this is the idea that we want to chain things together, okay? You have a list, and you want to add to the list. So think about, if you've ever written yourself a to-do list and you want to extend it, you typically add to the end of the list. Or maybe to the top of the list if you're trying to add something more important to do. Your C++ homework goes to the front of the list. But that there's sort of this linked data structure, right? You're linking one item to the next here. And this linking here doesn't just have to be in sort of this linear order here. It could be front to, it's sort of one direction here. It could be going in the reverse direction or both directions. But we can also create more interesting data structures like trees and these sorts of things, okay? So where I have some root node at the top and then I link it with something below, right? You could think of this like a family tree. Or maybe a graph, right? You see we have multiple sort of nodes here. And this is directional, right? There's some arrows here. So this is, a sort of type of data structure that we can build. And we'll look at how to build this with pointers. Again, not something built into the STL here necessarily. Like a graph or a tree, for instance. But we do have lists, and it's important to know that behind the scenes, they're sort of linked in this manner that they can be extended one item at a time. Okay. So these are our basic building blocks in C++, and these are what folks are using to build that library of data structures that I mentioned, the STL. Okay, so we have these raw arrays, contiguous blocks of memory, and then some way to link those pieces of memory together. Okay. Now, eventually, we'll use these primitives to create our own data structures, as I mentioned. But for now, again, let's look at the standard template library. Okay, so first thing that it gives us is a array data structure. So I said, hey, I already have an array, but there might be more interesting things that we want to do with it. So again, if I just look at this raw array here, right, this is just basically, we're sort of counting on us to remember that, hey, we've got this chunk of memory, it's 9 elements, in size. But how do we keep track of that? Well, some smart people in C++ said, let's create a data structure for that, okay? And add some member functions so that we can act on this array, okay? So it's actually an object that we're creating here, okay? So think about your Java programming a little bit. If you've taken Java or even Python where you have objects, this idea that I'm creating this data structure, this container that says, hey, I'm going to store integers and 5 of them. Right? So you can use it just like the old array that I just showed you where you're assigning things, but you also have these handy other functions here where you can do things like .at, okay? And .at is interesting because if I supply .at -1 or a million, it actually provides an error that I can capture, right? Versus just crashing. Okay, and then there's some other things here like front, back size, max size, and so on, okay? So let's go ahead and explore this a little bit here, okay? So anyways, here's the parts of the array here. So what I'm going to do, and this is a good thing for you to do if you're following along today, is to go ahead and just grab some of the code from Module 2. So what I'm going to go ahead and do is show you how to do this. I'm going to go ahead and go to our code samples. And let's go ahead and just clone this whole repository. That way you'll have everything. I might push some new stuff in here later, but for now this is what we got. So do git clone, right, just like you did with your mono repo. Looks like I already have it here. let me just cd into this directory here. And if I do git status, it looks like I modified something. Let's just blow this away here. So I'm going to remove that whole directory, and let's just go ahead and clone it again. And this is a public repository, so you don't have to enter your name or anything like that here. Okay, and then let's go ahead and I'm going to split my window up here just so I can kind of show you a little bit more what's going on. Let's just run that sample file. And usually, again, I try to be good, not always, but I'll write the name of the file at the top here so you can see what's going on here. All right, so let's go ahead and open up. Let me go into this directory and then split my window here. Open up in module 2. Oops. Sorry, let me do this one more time. We're in the second directory here. Now I'll split my window. And let's go ahead into standard array. And for whatever reason, I called it standard array 3. Because we had the other raw array examples. Okay. So let's just go ahead and compile this just to see what it does. So again, G++, we're using modern C++. So you need to use at least 11. You'll often see me use 20 or 17 because I like to use the new stuff. Standard array 3, and then we want to output this as program. And let's go ahead and run it here. Now it doesn't really output anything. Which is kind of the point of this next exercise that I'm going to do, because we want to know, hey, what's at the front of our array, or the back, or the size, or the max size. Now what I could do here is go ahead and sort of do what we learned here, standard cout, my array front, and put an end line here, okay? And then if I go ahead and compile this and run it, then we get some output here. Okay, so is 9 the first element? Well, yeah, I just changed it here, okay? And that's what the front member function does. But I don't want you to necessarily have to litter your program with all these sort of output statements, right? It is one way to debug, but as we're learning C++, I want to go ahead and teach you some ways to debug here. Okay, so how do we do this? We're going to be using a debugger known as GDB or LLDB, okay? Depending on whichever one you want to use, it doesn't really matter. In most of the lectures in this class, I shouldn't say most, but many, especially towards the start, I'm going to be teaching you a little bit of a debugging skill here. Okay, so I'll be using this tool called the GNU, which basically stands for it's just a free debugger that's available. Okay, so if you need it, you can do something. If you're working in the virtual machine, like sudo apt-get install GDB for the GNU debugger. Otherwise, there's installations available. You can just search online and download. Okay, but let's go ahead and take a look at how this could be used. Now, I will say, some of you might be using. Again, I recommend doing everything through the terminal, just sort of as I'm doing. That way, nothing's hidden. But if you happen to be using an IDE or something, you'll likely have similar ways to sort of debug your program. Okay. All right, so let's go ahead and start with debugging here. Let me make this slide a little bit more clear just so you can see where it starts and stops, I guess. And I'll usually have this sort of step-by-step of what I was doing here. Okay, and where I want to start here, let's go ahead and just look at this program here. Here is by launching GDB. Okay. Now, how do I do that? Well, there's actually 2 steps that I need to do here. The first is I need to compile my program, but very important, I need to add a -G here, okay, and then I'll hit enter. And what -G is doing is it's saying, hey, input some debugging symbols, okay, into this program here. And that's basically, you can think of it like putting in comments into the actual machine code here to ensure that we have some information that when we go through the debugging process that we can see what's going on here, okay. So here's your sort of cheat sheet as to what's going on here. I don't need this, so let's just go ahead and run GDB. And then the argument in the program is, well, the executable that we want to run here. So prog, or if you're on Windows, prog.exe, and then you hit enter. Okay, and that's going to tell you a whole bunch of stuff, like what version of GDB you have and so on. Okay, and then you'll notice I have this prompt here, and that means I'm within GDB. Okay, let me go ahead and just hit quit, just so you know how to quit here. I'll clear my screen, and let's run through this process again. Again, compile our program, being careful to do -G, and then remembering our program name, and then launching with GDB here. Okay. Now I could supply other arguments here, which sometimes I'll do like silent, and then we won't get all that information here. But you will get this one little printout here that says reading symbols. That's the debugging symbols that we got here from our program. Okay, and then it says done. Okay, so let's go ahead and just start our program. So I'll just type in start. Oftentimes you can just do S for some of these commands, but there happens to be a different S command, so start. Okay, and it's saying, hey, we're starting our program here. Here's where I am here. Here was the source file. And again, we know the source file because we have debugging information here. And we have a temporary breakpoint. So we're just sort of stopping or pausing at main here. And main, again, is the entry point into our program. So we want to not pause, but actually start executing. So I'm just going to type in next here. Okay, we'll move to the next line. And look, this is the next line that we're about to execute. And I'll type next again, next again, next. And you should notice that some of these statements are familiar, right? These are, if I look at our program, if I go back a slide here, right, these should be familiar here, right? These are all these lines of code here, okay? All right, let's open up or continue on with our debugging process. And maybe we're just done, right? We're sort of stepping through this one at a time saying, hey, execute the next line, the next line, the next line. So what I'm going to just do is say continue, and that'll just keep running our program until it exits. Okay, so that's pretty neat here. Okay, now let's run through this a few more times here, and you're going to get some practice here. Like let's say we want to start our program again, and maybe just continue, and then it's done here. Now something you can do to make this a little bit more interesting is start your program, and then I'll type list here. Okay, and now things are getting a little bit more interesting because you can actually see the source code in some context. Okay, so the list command usually centers around the actual command that you're about to execute. Okay, and then I can do next here, and then list. If you type out refresh, that'll usually clear your screen. Oops, mine went into this thing here, which I don't want to show you yet. Let's see, so I need to go here. Let's see, Control X. Let's see. Oops, bear with me here. I didn't want to show you that quite yet. Let me just exit or do Q. That's how you get out of a debugging session when you're paused here. I'll show you that in a second. So let's restart GDB, list. Just kind of shows us where we are. Start our program, list so we know where we are, do the next thing. You can just do Control L, which clears your terminal. That's usually what I want to do here. And then list here. I'm going to do the next thing. Then Control L, and then list. And again, I just like this because it gives me context. Okay, so this is what I'm about to do here. Okay. Okay, so let me show you that cool thing, or what I think was cool here. And you'll see it here at line 2 with program here and --TUI here. Okay, let's go ahead and try this --TUI. And this gives us what's called the text user interface. And this is something that a lot of folks don't know about. To say, okay, and this kind of shows us our source code while we're debugging. Okay, so it's the TUI or the text user interface. Okay, so now we can use the same commands that we started. We have a prompt here. We do start, and you can even see, look, there's that breakpoint thing here. That's what it's telling us here, temporary breakpoint. So you get a little B here, and then where we are executing. And then we do next. Okay, and then we do next again, next, and then. I'm actually getting tired of hitting next. I'm just going to hit enter a few times. And enter is just going to repeat that same command that we did. Okay, so that's the idea, enter, enter, and then we're at the end of our program here. Okay, so you can see it kind of gives us some information out here saying that we are effectively terminating. Okay, now I can restart again, and it'll ask me, do I want to restart from the beginning? Yes. Okay, so let's go ahead and do next, enter, 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 etc. Now at this point you're saying, Mike, you've shown me this like 5 times. I've practiced with you. And now I want to see something interesting. Okay, so let's do something more interesting. Let's actually go ahead and print, and again, this is the key term that's going to help you not have to write standard cout for everything. And we'll just type print my array at, say, 0 here. I'll hit enter. And look at that. You actually get as the output 9 here. Now this $1 is just sort of a temporary variable they've created. But it's actually showing 9 here. And I can do these other things here, like print my array dot front. Okay, and I also get 9 here. Now let's go ahead and say print my array dot back. I wonder what's in there. Okay. Oh, okay. This is just actually garbage of some sort because, well, if we look at our program here, I don't actually see anything. Okay, which is kind of interesting. So I could. There are some ways you could use like a set command and set it within GDB. But what we probably want to do, and I'll just go ahead and say focus on the source window. And then now I can hit up and down and sort of look and double check and say, hey, did I actually set that array value? No, I didn't do that. Okay, so let's go ahead and type focus command and go back into our command prompt so I can type here below. Okay, so that's the idea here. Now let's just go ahead and do next. Now these are member functions. It means they're doing something probably interesting there. So I can actually do step, which will go inside this function, or just s here. Okay. You actually can see now I'm somewhere else into the actual C++ library, something that we didn't write, right? I didn't see this anywhere, but it's got the actual size function here, which is kind of cool. Okay, you can see it's telling us where we are here. Now this is a little bit scary. I don't know what this is, so I might want to just type finish and be done with that. Okay, and that effectively ends that function call and brings us back to where we were. Okay, so let's go ahead and do next, and then enter again, and then enter again. Okay, let's go ahead and quit. All right, so at this point, what I want to do here is just again. You'll have to practice these things. So with every lecture, I'll probably be teaching you a tool or two, but at least at the very basics, knowing how to start your debugger and then move next one line at a time, and then maybe print something out. That's where I would sort of go with these sort of things here. Okay, that's the idea. Okay, so we can sort of execute or step or move one line at a time, and then you're good to go. Okay, so that was a little in-class video exercise. Okay. And again, Mac users, if you want, you can use LLDB. Let's see, I might have LLDB on here. I guess not. So you could do something like sudo apt-get install LLDB. You might have a version of it. Again, for Linux folks, you probably want to use GDB. It's what's native to the Linux platform. Windows folks, if you set up using MinGW, you can just use GDB. As well. So let's go ahead and try LLDB with our program. And here we can see we have it sort of starting and ready to go. Start's different. I think it's run. That'll actually run the process. We don't really have a GUI in LLDB though. That's why I don't really care for it as much. We sort of do, but I don't really know how to use this thing well here. Right, so I gotta do F1 here. And hit exit. I think process. Let's see here. Launch. Again, I gotta watch my own video to remember all these things. But LLDB. Usually, what you want to do is put a breakpoint, maybe at the main here. Let's see, break main. B just for short here, and that'll put a little pause at our main that we learned about. Okay, and now I can type in run. And you'll see this is the line of code that we're about to execute. Okay, and then you could do N for the next thing, the next thing, the next thing. And this does a pretty nice job for us. We don't actually need the TUI. It's actually printing out some information. Next, again, I can step into size here. Doesn't look like it let me do that. Let's try step again here. If you can't get into it, you can't get into it. It'll just move you down here. Next again, and so on. Okay, so that's the idea here for you to compile your program with -G and walk through it. Now you might have more success. Again, this is sort of for the LLDB folks if you use Clang compiler. I don't have that installed here right now. At least the latest version here. Let's see. I have that. Let me just run through LLDB one more time. Let's put a breakpoint at the main function. And again, I'm going to show you this stuff multiple times so you don't have to memorize it all now. And then sort of run our program and move to the next thing, next thing, next thing, next thing. You can try to step into it. Again, doesn't work. Let's just quit. Okay, so that's enough debugging, I think, for today, this sort of exercise. Okay, and then you could practice online too if you're having trouble installing things. All right, so I have a bunch of other lessons on this, of course, that I'll be distributing to you. And here's sort of a fun free video here, or a cheat sheet. Okay. All right, so at this point, this is a lot of different instruction. Let's see how far we are on the recording. So yeah, we're about a good chunk through. Again, things run a little bit faster when I'm recording because we're not interacting. But go ahead and give yourself a break if you need, and then we'll go ahead and resume. All right, and if you gave yourself a little bit of a break to let some of that information sink in, let's go ahead and resume back to the STL here. Okay, so what were we talking about before that digression? And again, my point is in showing you GDB is so that you don't have to, while you're learning this stuff, just write tons and tons of programs with cout statements. We want to do it in GDB. So other important data structures here, the vector data structure. Okay, and this isn't to be confused with the mathematical vector. Vector itself is a resizable array. We call it a dynamically sizing array. So I can create this vector here as such, and then I can actually reserve some memory so I have more boxes here. And I can actually resize it later, or as I push in more elements here into this data structure, it'll resize for us. Okay, and that's again the reason to use these data structures, because they're managed and sort of resized for us as well. All right, so here's the vector again. The available functions, member functions, and member variables. Again, in Java, that just means methods, which you might be more familiar with that. But the different things we can do, like look at the front, look at an individual element, assign it to something, etc., etc. Okay, so here's just another example of using vector here. So in this example, we just create the vector. Notice no size this time that we're specifying between the little angly brackets, which again we'll talk about why we do this, but for now just know that this is a vector with integers in it. Okay, and then we're going to push back elements 1, 2, 3, and so on. Okay, and then we have a little dot at here, and then to see the element here, and then we can remove the last element, pop back. So you remove the thing, pop it off, and then we print everything. Okay, that's the idea. Okay, now this time I have the same exact code as I just showed you, but I want to go ahead and show you the little change here that I put in float here. Okay, so I'm going to flip between these slides a few times just so you can see here what's going on. But float this time means we're storing floating point values, which float means like decimals, so things with decimal values, no longer just integers, right? Integers have to be -3, -2, -1, 0, 1, 2, 3, those kind of numbers. Floats can be any sort of decimal, positive or negative, right? So this is the type that we're putting in between the actual angle brackets. Okay, and this is where the whole idea of a generic data structure comes in, this idea, or generic container, this idea that we can put any sort of data type here, whether it's integer, float, or these types of things inside of our data structure here. Okay, all right, so what we've seen so far, and again, these examples, it's worth running these, right? There's a bunch of different examples here. That was the vector in vector 2 example. Let's just go ahead and open up one of these here. STD stands for standard. Vector, let's do vector 2 here. And then you can just go ahead and see this example here. And let's go ahead and compile it. I gotta type this out. G++, the standard, the language that we're using. Let's use at least 11 here, but I usually put in 17. We want to output it as a program. What program are we compiling? Standard vector 2 CPP. Okay, and there we are. Okay, so this printed out two things because we inserted one, or we inserted 3, and then we, sort of accessed an element here. We didn't really do anything with it. Then we removed the last element here. Okay, so 3.2 never actually gets printed out when we sort of iterate through the entire vector. Okay, so here's our for loop for doing that. Now this isn't using any special iterators or those kind of things that we have to talk about. We're just saying, hey, from index 0 to however big our vector is, increase every time that we run through this loop and just print out everything. All right, so let me make this smaller and jump back into the slides here. To recap what we've done here, okay? We've learned some data structures that exist, arrays that just give us a fixed size thing, right? When we pass in the type and then how big it is, right? Vector, which we just say, okay, I want this sort of resizable array. That's the idea, okay? So let's just take a quick look at some other data structures that we have available, and then we'll sort of wrap things up here. I've got a queue here, okay? So again, what's a queue? Well, it's a first in, first out data structure. Just like, when you line up to purchase your groceries at the checkout counter, the first person who was there will be the first person who has to pay for their groceries, and then the first person who gets to leave the line here. Okay, so you can see when I'm putting in things into the queue here, A, B, C, etc. You can see how the front of the line, is moving here. Okay, so that's the idea. Now, a queue could be a fixed size, or it could be something that grows indefinitely, right? You could say, hey, only 6 people are allowed in this checkout aisle. Otherwise, go wander around the store somewhere or whatever. That's sort of the idea here, okay? Or it could be, and you have to see how it kind of rotates in this way, okay? So queue, again, a little bit simpler data structure, right? We're sort of just pushing elements on and popping elements, and we can kind of check out what's on the front, and that's really it. For the size, how many elements are actually in the queue. Okay, so here's an example here. And again, I'd encourage you to run this. And then we've also got a stack data structure. Okay, another sort of fundamental data structure. This time last in, first out, so I'll give you a moment or two to study this visualization and try to understand what this is like. The analogy is using dirty dishes usually, or when you wash your dishes, how, the last thing in, which would be on the top of the stack, is the first dish that you wash. Okay, so that's the idea. Stack we'll want to be a little bit familiar with. Again, some of you know this. Some of you have taken a data structures course, data structures and algorithm, and some of you this is new, or you just haven't seen it for a while. Okay, so again, here's some of the member functions available. Okay, this time we do have a top thing that accesses the top element. That's a little bit different than queue. We had our front element, and we actually have a way to access the last one as well. Okay, so here's another example with a stack here. All right, getting into some more interesting data structures here, we have maps as well in C++. So maps are associative data structures. Okay, so they have a key and a value pair here. And the idea is that your key goes through this hashing process. Okay. Because your key could be something like your name, or it's got to be something that can translate, right? We have this hash function that translates anything into some unique value. So let me give you some examples of unique values. Your social security number should be a unique value, at least per country that you're in. Some other unique values, right? Your phone number, right, would be the key, and then the value would be your name. Okay, that's who you are here. Okay, so there's got to be some sort of strategy to take some information, organize it, and then that's the key, and then it'll have an associated value with it. Now, behind the scenes, a map data structure in C++ is organized as a tree here. Okay, and we can sort of search through trees. Maybe you've done sort of a binary search. Again, we'll have to talk about some of these things and actually practice building them. But this is the idea here, right? And because we have some association, this is a quick way to look information up. So in the instance of phone numbers, right, if you have a phone number that starts with 617 or say 614, that immediately, 614, 1, 2, 3, 4, 5, 6, 7, or whatever the phone number is, that immediately tells you, well, 614, the area code, right, to maybe look in the left side of the tree where you're storing all the Columbus, Ohio, phone numbers, okay? So that's the idea of this sort of associative data structure. You don't have to search through all the information, just sort of parse through this tree, okay? So map, that's the kind of data structure that's built in. Again, you don't have to build this type of tree. It's usually some kind of balanced binary tree, a red-black one, usually. That's how it's implemented. That's the idea. Okay, so let's take a look here. Again, these are the different things that we can do, things like find elements and so on. Now again, when we're creating this map, we need to create a key and a value pair. So here's an example here, a dictionary. That's another classic example, and that's also another name for a map. But you take your key as a string, that would be the word, and then the value would be a string, the definition. Okay, and then you create a key value pair. So let's go ahead and create a pair. So again, it's a key is a string, value is a string as well, and here's the actual thing. We're going to name it cat. That's the key, and then the value is going to be a funny animal. And then you can insert it into this map here that we've named dictionary. Okay, and then when you want to look things up, you look up the value by the key, right? So I put in dictionary, and then in brackets, instead of putting in a number, right? So it's different than an array. I could put in a string, I put in cat, and then this allows me to retrieve a funny animal, okay? The actual definition of this. Okay, so that's the idea. Now that's just one of a type of map data structures. There's actually something called unordered map as well, which is a little bit more efficient. You know, it makes a trade-off that the elements aren't going to be stored in the order that they were inserted. They're just going to be put somewhere. Okay, and this is usually a bucketing strategy. Again, we'll have to look at this data structure. We'll have to actually use some of these so you can internalize them. But the idea here is that you know, I have this bucket here with or a way, I guess, to create a bunch of buckets where things might fall into. Okay, so let me sort of put it this way. So if I had your name, or I'll use myself as an example, Mike, and I'm one of the professors at Northeastern, right? I would sort of want to put this into some logical bucket, right? I'd have a bucket here called Corey College. Okay, so if someone was searching for information about Mike's specifically, right, I would fall into this bucket, right? And then you just have to search this one bucket rather than search for everything, okay? And that's the idea, okay? So in other languages, Java or something, maybe you've used hash table, but that's this idea, okay? And the hash function, the thing that picks which bucket, that's a little bit magic to us right now, but you know, we'll figure that out later, okay? So anyways, we have lots of more power here. Okay, and we even have things like hashing policies and different things that we can sort of mess around with. Okay, so if you look carefully, again, all I've done with this example, this is our same one, right? If I look here, you know, I've got the cat, that's a funny animal. All I've done is change this header file that I'm including, right? And this is what gives us access to each of these containers. I've somewhat omitted that in the examples, but maybe you've noticed I have include and then what the actual data structure is. Okay, unordered map here. Okay, so that's the only thing that's been changed. All right, so some other data structures, sets we have. So like you might have learned in discrete math, right? But this only allows one unique key here. Okay, so this is a little bit, again, right, if there can only be one Mike Shaw for whatever reason, there's actually many of us, but this would be, you know, a set, okay? So, right, in a dictionary, I probably only want one definition of a cat, for instance. So that could be one instance to sort of use a set, you know, or maybe one application for a job, right? You don't want Mike applying for, you know, many times so that I fill up the entire data structure, right? I just want Mike Shaw to apply once in the job application database. Okay, so some similar member functions. Now, I've been kind of flipping through these quickly, right? We haven't done an in-depth detail, but what you're going to notice in the standard template library is a lot of these things kind of look the same, right? There's something for size, find, or count, you know, inserting things. And the library, again, and a reason that we're learning this is it's pretty uniform, right? You can almost, like in this example where I said, hey, unordered map, and then when I go, you know, a few slides back in map, I didn't have to change any of this other code, like .insert was the same thing. So again, that's kind of cool, that's kind of elegant, that tells you that folks thought about how we're going to use these actual data structures. All right, so let me get to sort of wrapping us up here. As we're approaching the end, I'm going to give you a little bit of a thing to do. So basically, you know, it's worth noting that we don't have every single data structure available to us. We don't have things like graphs, for instance, because we really need to think about how to represent a graph. That's a little bit of a bigger task. We don't have tries. That's how this is pronounced, which is a cool data structure we'll have to talk about. They're not built into the standard template library. Maybe they will be added later. Maybe there will be a version. You know, we don't have everything, certainly. Okay, so that's the idea. All right, so today, in summary, you know, you've learned about several data structures, how to inspect them, you know, do a little bit of debugging with GDB. That's the big part. And what I want you to do is, well, complete the in-class activity. If you want to learn more about these, this one's probably a more advanced talk, but might be interesting. But Bob's talk would be an optional sort of assignment if you find yourself wondering, you know, what else to do here. But what I'd like you to actually do, and this is, you know, typically, let's see. So an online lecture here, you've done about 50 minutes. So typically, you know, in real in-person time, that would probably leave us at least 20 minutes. Probably not all 50. Again, it goes faster online, but to actually run through some of these examples. So I would like you to actually download the Git repository, right? And you've got all these samples. So actually run through some of these and run through them with GDB, right? Compile them, run them with GDB. That'll ensure that you're getting set up with these, or LLDB, that's fine as well. But just some way that at the very least you're comfortable typing in GDB program, maybe TUI, right, to get used to that. And at least knowing how to start and then go ahead and hit, you know, next a bunch of times here. Okay. Now this time, I guess let me end on this. You'll notice that, hey, when I start the program, it says I'm in main, but my source code isn't showing up. Well, what happened? Let me go back here. Oops, I forgot -G. So that's what you're going to see sometimes when this happens. So I'm glad I make that mistake every once in a while. And now this time you'll see, oh, voila, my source code is here. Okay, so that's just something to keep in mind here. Alrighty, folks, I'm going to go ahead and exit there, and I'll leave you to it. I'll link in that LLDB exercise, and then otherwise I'll see you virtually again for the next class, and then in person next week, which I'll look forward to. All right, I'll remind you that as well. All right, take care, enjoy the video, and get some practice in with GDB and typing out some of these examples.